I want to talk about the 4 tips I would think of as being the most important ones if you're just starting out on Haskell. So the first tip is we use recursion instead of loops. So let me explain this with my running example here. So if you compute the function, if you define the function that computes the length of a list, then maybe in Python or C you might use a for loop or a while loop. But in Haskell we don't have loops in the traditional sense, so we use recursion instead. And let me write this down. So we say the length of an empty list is 0, and the length of a non-empty list is 1 plus the length of the tail of the list. So how is this a recursive definition? How is this a recursive function? So if you look at the second equation, then it tells us that the function length is defined in terms of itself. So this is a circular definition. And generally we are told circular definitions are not good definitions, so it's worth thinking about why this works. So let's look at this. We see that the argument on both sides of the equation gets smaller if we think from left to right. So on the left, we have a list which has an element and another list. And we call also the element the head of the list, and the axis also called the tail of the list. And then we see that when we make the recursive call, we only use the tail of the list. So the list gets smaller in the recursion. And then also we have a base case. So that with each recursive call, the list gets smaller. And then when we hit the smallest possible list, which is the empty list, we say that the length of the list is 0. So this is recursion. Now, another important thing to keep in mind is that we have no assignments. So this looks strange if you come from imperative programming languages. No assignments. So let's look at our example again. You might say, oh, but there's an assignment symbol here, an equality symbol here. But it's really not assignment, even if it looks like, and if it uses the same symbol. So if we write down the equation that the length of the empty list is 0, we're really just writing down an equation. You can think of this as a mathematical equation stating a fact about the function length. And the same for the other equation, which is telling us that the length of a non-empty list is 1 plus the length of the tail of the list. And so really we should think about these equations as we think about equations in high school algebra. So if we see an equation like 1 plus 1 equals 2, or 2 times 3 equals 6, this just states true facts about arithmetic. But still, we can use these equations to compute, right? So if we use these equations from left to right, then we can use them to compute with numbers, and the same happens here. If we use the equations from left to right, we can use them to compute properties of programs, values of programs. So maybe one last remark here with respect to the equations is that mathematical equations don't have a direction, but equations in Haskell that define functions have a direction. We always compute with them from left to right. Okay, a third important difference is that we prefer not to use if then else. Haskell has if then else, but rather we prefer to use pattern matching and case distinctions. So we can also illustrate this nicely with our program length. So in an imperative programming language, we would probably say something, if the list is empty, then return 0, else go into the body of the loop or something like that. So here we just write the two possible cases. One, the first case and the second case, the case for the empty list. And oops, this should be around parentheses. So often when we start writing a Haskell program, it's good to just start like this, right? So just write out all the left-hand sides of the equations that you need. And then the first case is telling us that what happens for an empty list. And the second case tells us what happens for a non-empty list. Also, we should emphasize here that we use pattern matching to name the parts of the list. So we name the head of the list X, and we name the tail of the list X's. And then on the right-hand side, we can use these names to define what this function is supposed to do in a recursive call. So here, for example, we can say that we compute first the length of the axis, and then we do a +1. So we use pattern matching to name parts of data. Okay, finally, at this level, of course, real-world Haskell has lots of sophisticated features, but at this level, it's fair to say that Haskell has no secrets. So whenever you have a question about what your Haskell program is doing, you can just use the equation to do your computations by hand, like you do in high school algebra. So computation is equational reasoning. So let me illustrate this with a sample computation. So suppose I'm not convinced really that this recursive definition with pattern matching and so on works. So I can convince myself by just computing pen and paper an example. So I want to understand how Haskell computes the length of this list here. And so all Haskell is doing, it's applying the rules, it's applying the equation. So let me write down the recursive equation on top of that. So certainly we will want to start the computation in this example with the recursive equation, with the second equation. And now we use pattern matching, right? So length corresponds to length, and then the head of the list is 4 in our case, and also the tail of the list is -2 and 3. And now pattern matching told us the values of the variables x and x's. So having learned the values of these variables, we can now turn to the right-hand side of the equation and continue our computation. So the right-hand side of the equation tells us that we have to do a 1+ anyway, and then we have to make a recursive call to the function length. But also we now learned the value of this variable here, right? So the axes on the right-hand side have the same value as the axis on the left-hand side, and the axis on the left-hand side are the list -2, 3. So I put -2, 3 here. And from now on, we just keep repeating the same. So we need to compute the length of -2, 3. So we do another +1 and another recursive call to 3 now. And then we keep on going. That's what recursion is all about. So we keep on going here. And then at some point we hit the empty list, which is our base case. And we use the first equation, which tells us that the length of the empty list is 0. So we put 0 here. And now we're just left with a little bit of arithmetic, and we computed the length of the list is 3. So whenever you have a little Haskell program that is behaving in unexpected ways, make a little pen and paper example with a computation like this, and you should find the rule where something goes wrong. And then you should be able to fix the rule, to fix the equation. Okay, so let me just quickly summarize what we have seen. So my 4 tips: Haskell for beginners, use recursion instead of loops, remember that you have no assignment, use case distinctions and pattern matching instead of if then else, and if you don't understand what the program is doing, do a pen and paper computation by hand. Thanks for watching.